Okay, so we're going to look at a harder question now. Basically, just more angles, the harder the question. So we have a putty ball. I've already put in the numbers. So it's 50.58 kilograms, 90 meters per second at an angle of 30 degrees. Steel ball, 0.75 kilograms, 12 meters per second at 20 degrees. Also define up as positive, right as positive. So I need to write two equations, one for the x direction, because momentum is a vector. So in the x direction, let's look at the putty ball first. The mass is 0.58. Again, the equation I'm using is P is equal to mv. The momentum before must equal the momentum afterwards. And momentum and velocity are vectors, so direction does matter. Times 19. And not only we should put our units in, but you get some long equations in this one. So just to reduce the amount of time, and just to make it easier to see the mathematical equation, I am not going to write the units in. However, you should. So because it's momentum is a vector, and velocity is a vector, we're just looking at the x direction right now. We need the cosine component of the velocity. I'm going to write minus 0.75 times 12 multiplied by cos 20 degrees. And that's equal to the combined mass, which is 1.33. The velocity is unknown. And it's acting at some angle theta. And for that diagram, I'm actually not sure. Will it move more to the right? Will it move more to the left? We're going to solve that when we plug in the values. So you may ask, like, why is this first term positive and the second term negative? The first term is positive because I define right as positive. So the putty ball is moving to the right. It's positive. The steel ball is moving to the left. That's negative. Now this whole left side of the equation, that's just a number. I'm going to subtract those two numbers, divide by 1.33. We end up with a value of 0.8168. And we should store that number in our calculator and round it at the end. V cos theta. So there is our first equation. And it's actually very similar to the previous one we did. So we will be doing a little more algebra as well. So in the y direction, is 0.58 times 19 cos 30. Now for this one, they're actually both going to be positive because both the putty ball and steel ball are moving up the page. So both in the positive direction, so 0.75, 12. Sorry, this should be sine, not cosine. I'm talking about the y direction now. Sine 20. And we end up with a 1.33 V sine theta. And we plug all this in. This comes out to be a number. That number is 6.4573 V sine theta. Now what we are doing is just do a little bit of substitution of these two equations. So equation 1 and equation 2. So this equation doesn't really matter which one, but if I look at equation 1, see what does equation 1 become? V is equal to 0.8168 divided by cos theta. So when I plug in these values, we get 6.4573 is equal to 0.8168 divided by cos theta sine theta. Pretty much the exact same thing as last time, so we're just going to divide out. We get 7.9056 tan theta. So we get theta is equal to 83 degrees. And if we plug in that angle back in, we get V is equal to 6.5 meters per second.